Good morning, everyone. Today we will study Chapter 3. We will talk about the conditional probability and independence in this chapter. And first, we will start what is the conditional probability. Now, let's review some examples we discussed before. Tossing two dice. Let's review this example. Tossing two dice. Suppose that we observe the first die is the number 3. Then, given this information, what is the probability that the sum of the two dice equals 8? Now, let's repeat this example, tossing two dice. So, each die has 6 sides, and we assume that the dice are made balanced. Each side number has the 1/6 probability to occur. So tossing two dice, of course, we will have 6 times 6, totally 36 different outcomes, right? So we can analyze this experiment. First, the sample space. Sample space S. We can denote all the outcomes as the index, like I and J in the parentheses, right? I and J are both starting from 1 until 6. So totally we have 36 different outcomes when we tossing two dice. Now here, suppose that we observe the first die is the 3. So we can define this event E. So when we define the event E, you can call let event E is the first die is 3, is the number 3, okay? The first die shows number 3. And we don't care about what is the number showing in the second die. It can be 1, 2, 3, 4, 5, 6, okay? Shows the number 3. So how can we represent the outcomes for the event E? So that will be 3. It's always 3 for the first die, and then it can be 1, 2 until 6 in the second die. So the outcomes in the event E will be 3, 1, 3, 2, 3, 3, like that. Okay, let's list all the outcomes in the event E. 3, 4, 3, 5, 3, 6. So of course, totally we have 6 outcomes in the event E. When we define the event E, the first die shows the number 3. Now let's read it. Suppose that we observe the first die is 3, then given this information, that means given the first die is 3. Given this information means we know the first die is 3, so that will be all those outcomes. What is the probability that the sum of the two dice equals 8? So we can let another event F, that will be the sum of two dice equals the sum of the two dice equals 8. And we know there are several ones, right? Several ones like 2, 6, 3, 5, 4, 4. They all equals 8. But here we know that the first die is 3. Given that we know the first die is 3, the first die shows number 3. Now, what is the outcomes? What is the outcomes in event F? So we know the first die shows the number 3 and the sum of the two dice equals 8. So the second number can only be 5, right? So we only have one outcomes. So if I define another event, okay, if I define another event here, the sum of two dice equals 8 without giving any information. Okay, without giving any information equals 8. What is this A? So this A will be, you cannot have 1 7. So 2 6, 3 5, 4 4, 5 3, 6 2. Right? So be careful, okay? Be careful to distinguish event A and F, okay? Event A and F. Event here, event A and F are different, okay? Event F is different from event A. Check the definition. Different is different from event A. So here, event F is the sum of the two dice equals 8. Given that means we know the first die shows the number 3. So we only have one outcome in event F, which is 3, 5. Now I define another event A. A is the sum of two dice equals 8. So out of the 36 outcomes, the event A will be 2 6 3 5 4 4 5 3 6 2. So we will totally have 5 different outcomes, right? So here try to tell the difference, okay? Try to tell the difference between event F and event A. Event F is different from event A. And how can we call this event F? So this event F with the given condition, given information here, then event F we only have one outcome. What is this given condition? That based on another event E, right? Given this condition is the first die shows the number 3. That means given that the event E occurs, right? The event E occurs, which gives all those six outcomes, right? Now, let's read the question again. Suppose that we observe the first die is the number 3, then, given this information, what is the probability that the sum of the two dice equals 8? So, here, we can denote the probability of event F. The probability of event F. What is probability of event F? So that is the sum of the two dice equals 8, given that the first die shows the number 3. So we know that the event E occurs, we have all those 6 outcomes with the first number is 3, and then the second number should be 5. So event F probability will be 1 out of 6, right? So the answer is 1 out of 6, 1 over 6, okay? 1 over 6 is the answer. And here, check the definition, okay? Check the definition. 7-1. In A, why not 7-1? It's tossing two dice. Can you have number 7 showing up in for a die? Of course not. We only have the number 1, 2, 3 until 6, right? And in another way, you can represent your event F, okay? You can represent your event F. Event F actually is the same as, why not 1 over 16? Because we already know that the first die shows the number 3. We already know the event E occurs. Event E occurs, so when it's only those 6 outcomes out of the 36, right? It's only those 6 outcomes out of the 36. And here you can represent your event F. You can represent your event F. Represent here actually we can represent F. We can represent the event F as the event A occurs given the condition event E occurs. Okay, we can represent. So the probability for event F can be taken as a probability when event E occurs. When event E occurs, or under the condition event E occurs, the conditional probability of event A. So that means, how can we read this one? So let me write it more specifically. Okay, let me write it more specifically. So here we already understand. Let me write the event first. Okay, let me write those events first. So event E again is the first dice number. First die shows number 3. Shows number 3. And what is my event F? Let me write event A first. Okay, let me write event A first. And what is my event A? My event A will be the sum of the 2 dice. The sum of 2 dice equals 8. And what is my event F? Event F is the sum of the 2 dice equals 3. Sorry, equals 8. Given that the first, so it's the sum of 2 dice equals 8. We know there are 5, right? There are 5. But given that the first die shows the number, show number 3. Okay, show number 3. So actually you can describe event F. Describe the event F. Use event A and E. Okay, I can describe the event F as this notation. Okay, as this notation. That is, given the event, given the event A, be careful about the way I stated. Given the event E occurs, what does event E occurs? You get all those 6 outcomes, right? All those 6 outcomes with the first number is 3. Then the second number can be 1, 2, 3 until 6. Given the event E occurs, then event A, right? So we use this notation to describe given the event E occurs. Given the event E occurs means given that the first die shows the number 3, then the sum of the 2 dice equals 8. So when we describe the probability of event F, that will be the probability of event A given the event E occurs. So actually you have the probability, and we assume that it's equally likely, right? Equally likely outcomes. Given the event E occurs, I will explain later, okay, why we get this final answer. And we check that event E has 6 outcomes with the first number is 3, right? With 3. And then event A, under that condition, when we have the first die shows the number 3, the second die can only be number 5, so it's one of them. So the probability will be 1/6. So that is the notation I use here, okay? So this one, we write the event E on the right side, put a vertical line, which means given the event E occurs, the probability of event A. Actually, we call the conditional probability of A. Now, let's check that, okay? Let's check that. So here, this is the event A I mentioned, okay? In my notation, okay? In my notation, this is the event A sorry, it's a little confused, So let me write here. So that is the event E I mentioned. Okay, that is my event E I mentioned. This is the event A I mentioned. So according to my notation, that will be given the event E occurs, the first die shows the number 3, then event A. Right? Event A occurs, the probability is 1/6. And we know that you can use different letter, right? You can use different letter to denote those events, and we usually can write it as E and F. Okay, now let's check the notation. So that is the condition or definition of conditional probability. Okay, conditional probability. So we usually write in this notation. Okay, in this notation, then we can read it. Put a vertical line. Okay, put a vertical line. So we read it. Given the event F occurs. Given the event F occurs, the conditional probability of event E, the conditional probability of event E. How can we evaluate this conditional probability? That will be the probability of the intersection, or the event E and event F probability over the probability of event F. And of course, the probability of F cannot be 0 since it's a denominator, right? Since it's a denominator. If the probability of event F equals 0, that means, according to our equally likely outcomes, that means the event F is the null event. So null event, the probability equals 0. We are not going to discuss that conditional probability. So that is the conditional probability formula. We can calculate or evaluate the conditional probability, but important part is how you define the given event F and then another event E occurs, or how can you understand the probability given is the conditional probability. Okay, I think the conditional probability, the formula is pretty easy, right? The intersection of those two events divided by the probability of this event F, which is the event occurs under this condition, the event F occurs. So the event F probability will be the denominator. Okay, will be the denominator. Now let's read it. Okay, let's check more statement about this conditional probability. When you write PF, event F probability as the denominator. So If each outcome of a finite sample space S is equally likely, that means the S having equally likely outcomes. So conditional on the event that the outcomes lies in a subset F, F is a subset of S. All outcomes in F become equally likely, of course, right? Since all the outcomes in the sample space is equally likely, so the subset, the outcomes consisting in the subset event F are all equally likely. Then in such cases, it is often convenient to compute the conditional probability when we take the event F as the new sample space. Okay, so here when we calculate the probability, conditional probability, so this one is given event F occurs. Given event F occurs. What does this mean? That means we take, this is equivalent, or we can understand, given event F occurs, we can understand this one as we take event F as the new sample space. Event F as a new sample space. That's why we get 1 over 6. Okay, that's why we get 1 over 6 before. Now let's review the examples we explain here. Okay, we explain here, and the notation we use usually will be event E given event F. Okay, given event F. So my event F becomes this one. Okay, that is my event F. It doesn't matter about the notation, okay? And this is even if we follow the definition in the conditional probability. So according to the conditional probability, that will be the probability EF, right? EF over the probability F, right? So what is E and F? What is the probability E and F? So we will check that. Those are event E and F. So that means the first die shows number 3 and the sum of the two dice equals 8. Of course, the event E and F is also a new event, but it's an intersection, right? Actually, intersection. The first die is 3 and the sum of two dice equals 8. Of course, we only have one outcomes, right? We only have one outcomes. So the probability, okay, the probability for this one actually, we're not going to talk about the probability first, okay? Then let's check the event F. Let's check the event F. Event F becomes this one. So the first die shows the number 3. So we have 3 1, 3 2 until 3 6, right? Until 3 6. So we have 6, right? We have 6. So actually we have one outcomes. If we take the F as the new sample space, take the event F occurs here, event F occurs. Take this event F occurs. That is the new sample space. How many outcomes in total? 6, right? That is the 6 outcomes, and this event E and F is just one of them. That's why it gives 1 over 6. Or you can do it in another way. Okay, you can do it in another way. Probability of E and F will be 1 over 36. Probability of event F will be 6 over 36. Right? Out of the total, so you still get 1 over 6. Right? That is how we understand it. The probability of those two events are just the probability based on the sample space. Only when we talk about the conditional probability, given event F occurs, we have a new sample space. Right? Be careful about those two probabilities. Those are the probability we talked about before, but this is a new conditional probability. Okay, conditional probability. And try to be identical with the notation. we will use this one, okay? We will use this one. Given the event F occurs, the conditional probability of event E. Now let's check the examples, okay? So a coin is flipped twice. It's also like flipping two coins. It's the same. Assume that all 4 points in the sample space are equally likely, right? A coin flipped twice, so we can get 4 different equally likely outcomes. Double head, head tail, tail head, double tail are equally likely. What is the conditional probability that both flips land on head? Given that the first flip lands on head. B, at least one flip lands on head. Now we need to figure out what is the condition event F occurs, okay? So let's define the event event E first, okay? Event E first. Event E will be, what is the probability? Both are head, okay? Both are head. That is the event E, right? And by the way, both are head. Both are head, which means you only get the event head. And we know the probability of event E is 1/4. There is no problem because there are four total different outcomes in the sample space. But the question is not asking the probability of event E. They ask what is the conditional probability that event E the event E occurs given some conditions, right? Given some conditions. Now I can call my event F1, okay? Event F1 is the first flip lands on head. The first flip lands on head. This is the given event, okay? Read it, try to figure out the logic, okay? Try to figure out the logic. What is the conditional probability that event E, event E will occur given that event F1 occurs? So this one occurs under the condition event F1 occurs. The first slip lands on head. What are all those outcomes? So event F1 will be the first flip lands on head. You can have head, or head, tail, right? You can have two, right? You can have two different outcomes in event F. Now, what is the question asked given the event F occurs? So they ask, what is the conditional probability both are head, given the event the first one is head, right? Given that the first one lands on head, then according to the conditional probability definition, that will be the probability E and F1 over the probability F1, right? As I said, the F1 becomes a new sample space. Now, when you are talking about the both are head, but under the condition both are head, this event E, what is the probability of the event E? Under the condition you have a new sample space. The event F1 will occur, the first flip ahead. So it's just one out of the two. Of course, the probability will be 1/2, right? The probability will be 1/2. The event E we only have one outcomes, and under the condition, event F1 occurs, that will be 1/2. Or you can work out one by one. Okay, you can work out one by one. So what is the probability of F1 based on the sample space S? Of course, is 2/4, which is 1/2, right? 1/2. Now let's figure out what is the probability E and F1. What is E and F1? Now let's try to understand. The here we have already introduced the conditional probability, but let's try to understand what is E and F1. How can we state this E and F1? So that means the first flip is head and both are head, right? What is the common part? What is the intersection of those two events? Of course, will be both are head, right? Even the F1 tells the first one is head, but even E tells both are head. So should be both are head. Both are head. What is the probability? E and F1. Of course, both are head. You only have one outcomes out of 1 over 4, right? 1 over 4. So according to here, you can also work out the probability of the E and F1 is 1/4. The probability of F1, that is 1/2. And from here, actually, when you're talking about given the condition F1 occurs, even the conditional probability of event E, you will notice that actually event E is the subset of the event F, right? Of the event F. So that is the conditional probability to answer the first question. Let's check the second one. At least given the condition, at least one flip lands on head. So here I have the event E again, both are head. Okay, both are head. And we know probability of E is 1/4, but that is not the question we ask, right? That is not the question asked. Then we define another event, at least F2, we call it F2. At least one flip is head. At least one flip is head, which means you can have one head or two head, right? So let's list the outcomes in event F2. So you can have head, tail. At least one flip is head. We don't mention which one, okay? So you can have tail, head, or head, head, right? So that means at least one flip is head. So find the probability both head under the condition or given the event at least one flip is head. So that is the probability E and F2 over probability F2, right? So given the condition, this event F2 occurs, which is we have all those totally is 3 outcomes, right? It's 3 outcomes. The answer is not 3 over 4, okay? The answer is not 3 over 4. The answer is 1 over 3, right? The answer is not 4 over 3. The answer should be 1 over 3, okay? 1 over 3. It's pretty easy, okay? Pretty easy question about the conditional probability, okay? About the conditional probability. F2 is 3 over 4. Yes, that's true. Okay, that's true. F2, here the probability of event F2 is 3 over 4. So actually, for those two simple questions, how can you get the 1 over 3? This event E is a subset of the event F2, right? Event E is just the head. So you need to figure out what is the proportion what is the number of outcomes in event E that also occurs in event F, right? So that will be that equals the number of from those two questions, okay? Number of outcomes E occurs number of outcomes in E, number of outcomes in E, and the number of outcomes here is not exact in the top. So that will be the number of outcomes in E, but also contained in F. But also contained in F. But also contained in event F. So how many? The number of outcomes in event E, of course, just one, head. And it's also contained in F, right? Just one, still just one. And then out of the number of outcomes in event F. So how many total outcomes in event F? 3, right? So that's why we call the event F becomes the new sample space, becomes the denominator, okay? Becomes the denominator. So that becomes the event F becomes the new sample space. And you can check the previous question is also the same, okay? It also applies the number of outcomes in E, but also contained in event F over the number of outcomes in event F. Let's check a little quick. So how can you get the answer 1/2? How can you get the answer 1/2? So the top will be the number of outcomes in E, HH, but also in F. Of course, we only have one outcomes for the top. Okay, for the top means the number of outcomes in E, but also contained in F1. And what is the denominator? Denominator gives the number of outcomes in event F1. So that's why it's 1/2. Okay, one means the outcomes in event E and also in event F1. And then out of the total number of outcomes in the event F1. So here the conditional probability has nothing to do with the whole sample space. The given the event occurs becomes the new sample space, okay, becomes a new sample space. But you need to define those events, okay, to analyze the problem and define the event by yourself. Then it will be more clear to work out the conditional probability. And this is a pretty easy example. We can just count the number of outcomes in the sample space, right? For all the event, it's pretty easy because the total number of the outcomes in the sample space is 4. It's almost time. Let's take a 5 minutes break. Then we will continue example 2.